Okay, let's start. Good morning, everybody. Thanks for joining us today in our already third Explained webinar. The reason we started with Explained is because we as a cybersecurity distributor notice how fast everything is evolving. To stay up to date with the latest trends and technologies is challenging, to say at least. That's why we try to shed some light on hot topics and give you extra insights on tackling tomorrow's problems. I'm saying tomorrow's, but also today's problems, because our topic today is very relevant. It's API security. API stands for Application Programming Interface. We know that APIs can make our lives much easier because we are integrating and automating all different kind of programs, and not only programs, but also data. But that communication channel between those programs needs to be secured, because this is a very high risk attack vector for major breaches. And now I'm going to give the word to Eric, who is going to explain more about API security. So enjoy and make sure you're listening and paying attention very well, because it's very important for now, but also for tomorrow's problems.
Yes, good morning, everybody. So my name's Eric Peters. I'm a solution engineer for...
Eric,
yes?
Sorry to interrupt, but it's the wrong screen you're sharing. We're seeing your presenter view at this point.
Oh, okay. That's not good. That's
all
better.
Right, great.
Okay. Yeah. Good. So good morning. So my name is Eric Peters. I'm a solution engineer for Northern Europe at SAL Security, and SAL Security is all about API security. So our tagline is never worry about your APIs again. But today we're mainly going to talk about the technology itself, the risks that there are today, etc. But maybe brief introduction of SALT itself. So SALT exists already for over 4 years as a company, and has its own patented cloud scale big data architecture to protect those APIs. And we'll learn in this session that big data analytics is what is needed for the newest threats in API security, because those attacks are more going onto the business logic and cannot really be captured with a simple signature-based solution. It's easy to deploy, not in line, so it's a very fast time to value. Just copy the API traffic to the SALT solution, and that's it. And as a company, we have strong validation from the field. We had some nice awards, and we also have Sequoia Capital and Capital G behind us as investors. But let's talk about the topic of today. So one question for all of you guys. So my question is, do you know one asset that is publicly exposed that has a pathway into sensitive data and into private data, and that is used to escalate privileges and compromise other systems? So if you have any idea what that could be, you could actually put that in the chat window. No responses, no guesses. Well, very obviously, it's the topic of today. It is the application programming interface, the APIs. So what is actually an API and how did the world change? So if we look in the past, we had traditional web applications built without APIs. So basically, when you went on your laptop to a website, you did a get for example, dashboard.html, which is an internet page that went to a server. The web server then fetched the user raw data on the backend from a database. That raw data was sent back to that server. On that server, you would render an HTML page, and that complete HTML page would be sent to the client. Today, the world is completely different. So what we see now is that there are different applications built, and the applications build the web pages, and the applications run on the client device, which can be an IoT device, which can be a web application that you connect to on a laptop in a browser, which can be a mobile application. And they do API calls, this example REST API, but there's also different types of API calls. Typically, they go to a gateway, but we see still a lot of customers that don't have an API gateway in place. And it's that gateway that then sends that to our modern apps, which are completely containerized and which run as different microservices. So you have all these little components that give back the information that is needed, but it's the application on the client side that actually builds that web page. And that is a completely different world, and that requires also a different way of securing things. So you could say that APIs are eating the world today. There was a famous saying, software is eating the world with the digital transformation. But nowadays, it's all about APIs. Around 83% of all internet traffic is actually API-based traffic. And the bad guys, they see that too. So what we see over the past couple of years is that there is a steep increase in API attacks. Last year, there was an increase of API usage of 300%, but an increase of API-based attacks of 600%. So it's going very steeply. There's a couple of examples here. They're mainly American-based. On Peloton, we go actually deep into detail what that attack was about during this session. And we should have known, because Gartner already predicted it in 2017, that by 2022, and if I'm not mistaken, that's the year we're in now, API abuse would become the most frequent attack vector there is. And they actually repeated that message December last year, in a sense that they say like, hey, if you didn't hear us in 2017, it's reality. And it's actually, we underestimated it. The rise is steeper than we expected. So what are the top use cases for API security? What we need to do, what we need to know to protect those APIs better? Well, at first we need to discover the APIs, and we need to get this visibility in shadow APIs. What are shadow APIs? Well, basically what we see is developers, they develop the APIs, they document them, and then they make changes, and these changes very often don't make it to the documentation. So there are all these APIs that nobody's aware of, that run sensitive data on them, and if you're not aware of them, well, you can't protect them, because as with everything in security, it first starts with knowing what's on your network. A second thing we need to do is see that we can prevent that sensitive data is exposed. And there's no problem in giving sensitive data out with an API, because the purpose of the API is to exchange data. But we have to make sure that sensitive data is only accessible for those that are allowed to get that sensitive data. We need to be able to stop those API attacks. Look at, for example, Facebook. Facebook, they had a breach of their API due to a little mistake of a developer. There was basically an API call where you didn't need authentication, but when you executed that API call, it gave you back the security token of a user. That has lasted for 1.5 years. So 1.5 years, Facebook couldn't find out where the breach was. And it was just a simple developer mistake. 50 million accounts were compromised before they were able to stop that. Which brings us to one of the other points, which you see below on the second in the row, reduce the time to investigation. We also need to be able to prevent account takeover, that people take over other one's accounts and go do stuff with it. We need to prevent data exfiltration, that API calls can be done to get all data out of a certain environment. We need to provide remediation insights, because it's one thing to do the runtime protection of these APIs. It's another to improve the security posture of these APIs, make these APIs itself more robust. So you need a solution that brings you insights in what the vulnerabilities in those APIs are and can help the developers tell them how to fix them. And we need to simplify the compliance. Today, compliancy of APIs is very often take all the Swagger files we have, which by definition are out of date and incomplete. We see at our customers that there is a discrepancy of around 40% what's in those Swagger files. And then it's a very cumbersome task to go through all these Swagger files to find out what data is being exchanged where. So you need something that can tell you very good where data is exchanged. So what's different today compared to the time before? Well, first of all, the attack surface itself changed. If you talk of APIs a couple of years back, it was very often some ways to program networking equipment. That was the first time I came into contact with APIs, that you could automate the configuration of those appliances. These APIs rarely changed. They were always backward compatible. Some things were added when new features were added to a product, but that was about it. And they had minimal sensitive data exposure. It was all about configuring those tools. Today, we see a very different world. We see that companies have API-first strategies. We see that they have thousands of APIs in some cases that frequently change because you have agile development. And every day, new types of code and new features are being checked into that product, into the agile development. And that makes that these APIs change continuously. They also today are the main exchange for sensitive data. So there is extensive sensitive data exposure through those APIs. And that makes it interesting, of course, for the attackers to get their hands on that data. But it's not only the attack surface that changed, it's also the attacks itself that changed. If we look in the past, we had some known attacks like an SQL injection or a cross-site scripting, which are typically the one and done single API calls. You try a call, you put in a field, or 1 = 1, which is an example of an SQL injection, and you see if you get a response. If that doesn't work, well, you try another one, and you try another one, and you try another one. So it's one attack. It takes seconds to minutes, and it's very easily detectable with signature-based solutions because it's a very strict way of trying to compromise those APIs. Today, attackers do it differently. They really start looking into the business logic of those APIs. And every API from every company, from every application is different. So can't really catch that in a signature-based solution. And even if you would attempt to, with things like positive security, where you learn how the normal behavior of these APIs are, it is not sufficient to detect those low and slow sequence of API calls, which is basically an attacker trying to figure out how these APIs work and then trying to manipulate these API calls once he understands how these APIs work, to find the weaknesses and to find the breaches. For example, the BOLA attack, which we'll go in more detail later. BOLA attack stands for Broken Object Level Authorization. This is where a user authenticated user tries to get data from another user by manipulating the API call. Maybe he sees that when he does a certain API call, that there is a user ID in there. What would happen if he changed that user ID in something else? Would he get the data back? Or would he be called back by the application on the backend server, telling it that he's not allowed to get that data? So that's the kind of breaches we're looking at. And SALT is not the only one that says that the WAF and the API gateway cannot protect those APIs. And that it has all to do with the architecture of those devices. These are more proxy-based, signature-based solutions that can look at one packet at a time. So they can't really correlate. So they can block the known attacks, but all these APIs have a unique logic. So how can you know about it? Today's tools, they block transactions. And if a user can just try new transactions, well, sooner or later, he will get through. So you need to be able to block the attacker instead of the faulty packet itself. They also have limited context, which leads to a high rate of false positives. So Gartner said it, and also OWASP said it. Approach of WAFs is not sufficient to properly protect critical applications. And Gartner says it's ineffective to do it. So let's look at the real threats itself. So many people are familiar with the OWASP Web Top 10, which exists already for many years. Well, already a couple of years, there's also an OWASP API Top 10, which focuses on the threats in API landscape. So they go like things with like broken object level authorization, the example I gave, where a user authenticates and tries to get data from another user. Broken authentication, where you could maybe get data without authentication, or you could manipulate the authentication or find weaknesses in the authentication to get in. Excessive data exposure, where lazy programmers give you back all the data and not the data that you're supposed to see. And then on the front end, filter the data that you should see and not see. A lack of resource and rate limiting, which makes brute force attacks possible, which makes it possible to do DDoS attacks on those APIs, or even get quicker out all the data once you find a breach where you could get the data. Broken function level authorization, where a user could, for example, have the right to get information, but if you change the function to a delete, maybe that works as well. Mass assignment, security misconfiguration, code injection, improper asset management, and insufficient logging and monitoring to complete the top 10. So we'll go into more detail of the first 5. We'll be a bit more technical. So what is broken object level authorization? So basically unauthorized access to access data. And how does it work? So on the left side, you see a very legitimate query where there is a request with a user ID in there. And we see also a cookie where there is a user ID and the cookie is linked to the authenticated user. So what we see in the response is we see the data given back for that user ID. So BOLA attacks can work in many different ways, but it always is about manipulating some of the fields that pinpoint a certain user. If you see on the right-hand side, on the attacker side, you see that the user ID in the GET request is changed to a user ID ending in 44. But the user ID in the cookie is still the one on 55. So basically, the user authenticated, the user who has the right to get to the application, is the user ending in 555, but he's asking information from a user which is not supposed to get the information back. But because the authorization doesn't map very nicely onto the authentication, he's getting the response back. And you see below in the response, the user ID 44 from the query with the data coming back, first name, last name, email address of David Miller, which is apparently the user in 444. So API protection solutions, they must be able to detect and to learn and to recognize when these numbers should be the same. In this case, the number of the user ID requested and the number of the cookie. And they should prevent that attackers, when two identifiers should be always identical, they should prevent that an attacker can manipulate one of them. To make it real, there was a BOLA attack on the Russian central bank, where they basically did such a thing. So there was an undisclosed amount of funds transferred with a fast payment system. And that was due to an API that did not cover well the BOLA attack. So basically there was a user that logged in with his account, looked at the APIs, looked how money was transferred from one account to another, and he saw that in the API call, his own account number was there. And he thought, what would happen now if I just use somebody else's account? So he said, let's transfer from a bank account that is not mine to an offshore out-of-country bank. And apparently it worked. So by exploiting the BOLA, attacker was able to fraudulently transact money from other accounts to an account he owned. Broken authentication. Authentication mechanisms are very often implemented incorrectly. They very often don't have the proper rate limiting to it, which makes it easy to do brute force attacks or credential stuffing attacks with high volumes. But there are also flaws in, for example, password recovery things. You could have a password recovery where you say, oh, we make it very secure, but because we're going to send an SMS to the customer's phone with a code, and he will need to give in that code in order to reset his password. But what if there is no rate limiting on that API call, and you can just, within a few minutes, and that code is usually valid for a couple of hours, or sometimes 15 minutes, but that's already enough. You do the calls of all the codes. And then one of them is the correct one. And you've resetted the password of somebody without access to the phone. So API protection solutions should profile an average usage of every API endpoint to see that abnormal behavior is being done, that there is excessive calling of a specific API endpoint. Authentication endpoints is very often the mistake of the implementation itself. We have misconceptions where people think OAuth is an authentication, but it isn't. It's just a delegation of authentication. That it's okay, people that think it's okay to use API keys to authenticate instead of users and passwords. Or that there are multiple authentication flows within modern apps where Java Web Tokens that support an algorithm to set to none, to not have anything encrypted, where passwords are stored without a salt, pun not intended, where a service does not validate that the correct OAuth provider is used, and that maybe in a query you could just cycle it back to another OAuth authentication or another authentication where you have all the control, these kind of things. So real world example there is Parley. Parley had a data breach where people were able to scrape 70 terabytes of data. And that was basically because, there were some of the endpoints that didn't even have any authentication. And we see that all the time in POCs, that sometimes on certain endpoints, the authentication part was just forgotten. Oops, now we can query everything from that API just by enumerating all the possible identities. Excessive data exposure. So that's the easy way out for developers, where they say, hey, if you do an API query for a certain endpoint, we'll give you back all the data and we'll solve what we will show you on the front end on the application itself. But that means that the data, although it's not being displayed in the application, is just being sent to the user. And that contains very often personally identifiable information that should not be available there. But there's a very nice example of that one as well. TreeFun. TreeFun is a group sex application, and it exposed near real-time location of every user. So you could see if he was at work, at home, on the move, wherever he was, you could basically see where he was. It also exposed data information like the birth, date, the sexual preferences, as such. It also exposed the private pictures of the users, even when the users in the application set it to private. And that was basically because when you did a query for a certain user profile, you got the latitude, the longitude, the birth date, the URL that contains the picture. Everything was hidden in the app interface, but if you can grab it from the wire, well, you can simply figure out who that person is based on his birth date or his picture. And what made it really fun is that, there were some of these queries pointing to users that were present in the White House and the Supreme Court. So what I'm wondering is, was it Trump? And if it was Trump, was it then Donald, or was it his wife? The Peloton breach. So Peloton is an application that makes it possible to track your cycling events. So basically, if you're cycling around, it tracks your exercises, your workouts, and it also tracks, and you can share that with other users. And the Peloton breach actually had all three of the top three API, OWASP API top 10. It started initially with broken authentication. So prior to disclosing the vulnerability, Peloton had, for certain API calls, simply no authentication in place. And the three APIs that were impacted were the workout details API, where if you had the user ID, you could very simply get all the details of the workouts that this guy was doing, and also access to some personally identifiable information. You had a user search API, which could help you to find that user ID in order to look at the other one. And then there was also a GraphQL data access API that gave lots of information. So GraphQL is a new form of API that is becoming more and more popular, which has the ability to contain very complex data structures. And that's the reason it's becoming more and more popular next to REST. So what we see here is, for example, the workout details API. So we have our API endpoint with the workout details. No restriction was needed, and it gave all the data back for any user. So if you had a user ID, you could ask for the user ID, you could find all the information like the gender, it's female, yes or no, his Peloton ID, his user ID, his username, his workout ID, the location where he was, in this case, Maryland, and all this information was simply available without any authentication. Then there was the user search API, which could help you find that user ID in the first place, and also gave you the full details of that user. So that could also easily be queried. And there was then the GraphQL API, where data was masked at the front end, but you could simply look at the traffic capture and get the data. Note that there's also some other exposures here. So you see that based on the name that the application is using Kubernetes, and you also see that they're using Apollo, which can be get from the headers, and could help attackers in finding vulnerabilities for certain Kubernetes deployments or the Apollo software. So now comes the fun part. So Peloton was told, hey, you have an A2 breach, you don't have proper authentication in place, and they were contacted before it was made public. And they reacted quite quickly. So basically what they did is they made authentication mandatory for each call. However, what they did not properly implement was the authorization that should go with it at object level. So basically, the A2, the authentication flaw, became an A1, a BOLA attack. Because any authenticated user could still ask the data from any other user. So simply what you needed to do now, register a user, and you still have access to all the data of all the Peloton users. And they also had an A3 in there. So excessive data information that is being sent out. So basically what you see here in the response is that the profile private link is set to true, but the response still gives all the data. It's only at the front end application that that data is masked when that profile is set to private. So that means if you just look in the traffic, you still have the data. Number 4 in the list, lack of resources and rate limiting. That makes your applications prone to DDoS attacks, which can lead to 500 errors. And what we see here is basically, we see on the left side, we see a legitimate post. And we see here that the max return is set to 50 and the page size is set to 250 as well. But what an attacker can try is to see if there is any limitation set to those numbers. So what if we now increase those numbers to 20,000? Now we need to get 20,000 pages back in one go. That could really have as an effect that the performance of the application goes down, or maybe even the application goes completely down. And if it's single-threaded, that, for example, other users now need to wait till you load those 20,000 pages. So API protection solutions should identify and report on those abnormal long query values, and they should be able to block them. Another nice one, the number 5, is the broken function level authorization. So what is broken function level authorization? Well, basically you're allowed to do one thing and you might not be allowed to do another thing. But what if you simply change the API query? What if you're able to read information via get command or to add some information via post command, but you shouldn't be able to delete stuff. Well, what if you just simply change the function of your post to a delete? Maybe that will help. Maybe that will work if it's not properly taken care of on the other side. So API protection solutions should baseline the typical access patterns for different user profiles to make sure that unauthorized these are restricted to the regular users and that only the admin level capabilities are restricted to admin users. So you realize that when we look at this example, for example, of the broken object level authorization, where somebody changes a user ID into another, that if you look at a signature and you look at what that API call should look like, that it doesn't really help. So you need context falling short on we see also that
Eric, there seems something wrong with the Wi-Fi because we're not hearing you
in
quite
place.
well.
I'm sorry?
We're not hearing you quite well. There was a lot of interruptions last minute.
You're not hearing me?
No, there was a lot of interruptions last minute. So I'm getting it from multiple people. So it's your connection, I'm afraid.
Okay. And now it's better?
Yeah, now it's good again, yeah.
Okay. Is there a piece we need to repeat or?
Maybe the last 2 minutes.
Okay. So yeah, broken function level authorization. So basically that's the idea that you can have certain functions like a get, a post, an update, a delete. And broken function level authorization allows users to use certain functions they're not supposed to use. So maybe a user is able to do a get and a post to add data and to get data, but it shouldn't be able to delete data. But if he changes the API call itself to a delete, maybe it will just work because the authorization is not fully in place. So an API protection solution should actually baseline the typical HTTP access patterns. He should look at how different user types behave, what the different profiles of users are, and should start recognizing that so that it can act on anomalies in that area where they suddenly see a delete coming from a regular user that is not supposed to do it. So the OWASP API top 10 threats, if we map them out to the classic solutions like a WAF and an API gateway and the API swagger, we can simply see that they fall short. If we look at that example of the broken object level authorization, so what we looked at in the slides basically is that this is happening due to manipulation of certain parameters, changing a user ID into another user ID and see if you get the data back from that other user ID. Well, you can't simply catch that if you look at individual packets and if you look at signatures, because signature-wise, that will still map to a user ID that will still look like a user ID. You need context, you need big data analytics to know and to recognize what's going on. And basically, if you look at the WAFs, well, they're not able to cope with any of the API top 6 in the API top 10. Oops. Are you still seeing my screen?
Yeah, but we're seeing your entire screen now, not just
Okay.
the presentation.
That's not good. Okay.
Okay, that's better.
And the same can be told for the API gateways. API gateways are very good in streamlining where the APIs go, that you have a single point of entry for your APIs. They're very good at, for example, mapping them to the documentation to see that the formatting of these APIs are properly done. They're very good at authentication, putting the authentication itself in place, but they're not good and not sufficient to cope and deal with those OWASP API top 10 business logic attacks. So what is SALT doing differently? So basically what we see is SALT security is offering three things. So first, it's giving visibility with the discovery. So it's giving a dynamic API catalog based on the traffic that it's seeing. So Swagger files documentation can be out of date, but reality will surface in the discovery. It gives visibility on zombie and shadow APIs. Shadow APIs, we already explained, are APIs that are not documented, but in use. Zombie APIs are basically APIs that should get decommissioned, but weren't decommissioned. So basically, you go with an API to a new version, or you create a new endpoint for a certain function, and the old endpoint or the old version of the API is still live. Very often not up to date to the latest security standards. And what attackers like is to find older versions of APIs that may be easier to breach than the latest ones. Sensitive data lake detection. Where is sensitive data available? Where is it being exchanged? Which is the data classification. What is the sensitive data? But also, where is it exposed, for example, without the proper authentication in place? Second thing that API security of SALT delivers is runtime protection. We can baseline these unique API traffics. API traffic for every application is different. We can recognize attackers are doing their thing very early in the reconnaissance, and we can block them. And we have a full coverage of the OWASP API top 10 and more. Where we have a little overlap with the WAFs, for example, is the cross-site scripting and the SQL injection, the code injection attempts. WAFs, on the other hand, are then a lot better to cope with, for example, layer 3 things, layer 3 protection for example, DDoS, and also the classic OWASP API, OWASP top 10, not the OWASP API top 10, which is more related to the web traffic as such. And then the third thing that SALT offers is an improved API security posture, where we can do a gap analysis of the documentation compared with the best practices, where we can do attacker fingerprinting, where we can look into the API vulnerabilities and create remediation details that can be sent automatically to the development teams to cope with. Other differences between, for example, the WAF and SALT is that SALT is completely out of band, so it's not adding any latency nor another additional point of failure to the data stream. It prevents business logic manipulation, and it works very automatically, so there's no configuration needed. WAFs are, on the other hand, very cumbersome to configure really well. So you can stop the base signatures and the common things, but if you really want to get to learn the applications it can become quite rapidly quite cumbersome to arrange it or to make it very strict. It's very good to stop the known bad and not good at stopping the unknown bads. The WAF, on the other hand, is in line and could help, for example, Salt to block an existing user. So if you want to have a full demo of the product, we can arrange a meeting. You can contact me or anybody else of the SALT organization to set up a meeting. Or you could also reach out to Exclusive Networks for a live demo. And then I would like to share you also some of the upcoming events that Exclusive Networks is organizing in the near future. But next to that, I would like to open the floor for questions. You could pose your questions in the chat window, or you could allow yourself or enable your voice and speak out. No questions, absolute silence. Stan, anything you would like to add from your side?
No, not really. I think it was a very good introduction about API security and why it's important. For me, it's still new concept. Like security was in my head like perimeter security, endpoint security. So this is something brand new. So maybe that's why we don't see that many questions. I think it needs to soak in a lot of people because it was a lot of information.
Yes, yes,
but
it is true, and that is also what we see when we talk to our customers, when we have first meetings and do a demo of our application. Then we see that we have different levels of knowledge within the field. There are certain CISOs and organizations that are very far in API security, that even have designated API security roles within the company. There are others that have heard there is an issue, but don't really know the details, think that they are covered with the tools, the firewall, the WAF, etc., that they have in place. And then there are others that have totally no idea, and sometimes even the first response of security department is sometimes even, but API security, that's not for us, that's for the development team. But then if you ask them, but who would ultimately be responsible if there is a breach? Then it very often comes back to the security team itself. So it's something that is on the rise. It's getting more and more coverage in the news because there are serious breaches happening. But still, there is a lot of learning to do. And that's very good that we could actually organize this session with Exclusive Networks to bring that to the attention.
Yeah, I think from my perspective, this is for the more mature customers who already have good security in place and looking for the next level of security. But maybe I'm wrong, and is API security also something that needs to be looked out for all those who aren't there yet, because it's a major attack vector for sure. Yes.
It's easy to say I don't know about it, and then I don't have to care about it. But once you're breached, it's of course too late. There was one question coming in from Davey via direct message. So how would you guide experts into getting more knowledge in this field, keeping in mind they are not developers? Yeah, that's a good one. And I don't think you really need to be a developer to have a quick understanding of what these OWASP API top 10 threats are and how they manifestate themselves. So you could read some of the articles. The OWASP OWASP.org website has a separate section on the OWASP API top 10, where you can find a lot of information. And yeah, if you share, if you would like, you can also find on our website salt.security, you can download a For Dummies book on API security. And that is a really good starting point to get to know more about API security. But I don't think you need to be a full developer to grasp what's going on in the API security, because after all, when you look at the details of such attacks, it is more coming back to looking at the network traffic itself and looking into those packets, what's going on, to learn what it is. And of course, a solution like Salt can help you find those attacks and can give you clear information about attacks that are going on, and also give you information on what type of attack it is. So it gives you the full details there.
All right, that's great. I think that's all clear. And just to make a final remark from my side, I know a few of my friends are developers and they don't give a damn about security. So if you're going to look at the developers for covering this, then it's going to take a long time.
Yes, indeed. Their purpose and their pressure is on getting applications out of the door as quickly as possible. There is coming more awareness towards the DevOps environment. Some companies are also starting with DevSecOps, which look at the security more. And Salt can deliver those teams very valuable information on how to improve the security posture of those APIs. But next to the shift left, which what this is called, it's also very important to have the runtime protection against the real day-to-day threats.
All right, great. I think we covered it. Thank you very much, Eric, for taking us into the API security world. And thank you everyone for joining us. And again, if you have any questions, you want to have some more information, have a live demo, just contact us at Exclusive or the people of Salt directly.
Very welcome. And thanks everybody for joining.
All right, great. Goodbye. Enjoy the day, guys.